Hello everyone, and welcome to a full beginner's guide on logic component blocks here in Stormworks. In this video, I'm going to be going through every single logic component block that we have here in Stormworks as of version 1. Now, as you can see here in front of me, we've got them all laid out. Each one of these have either got a number input represented by green, or it's got a on-off input represented by red. They've also got outputs. Once again, green represents a number output and red represents a on-off output. Now we're going to go through every single one of them. I'll tell you how they work, how you can change them, and I'm also going to show you an example of every single one of these. So let's get straight into it and let's get started. So the first logic component block that you'll find in your inventory is called an ABS. An ABS will always output a positive number. For example, if we were to give the system a pot number of 5, it output number 5 here. If we were to go and change that to a -5, this will also go and output a 5 value. It always outputs a positive number. The next thing we have is something called an add block. This takes 2 number inputs and output 1. You can take, let's for example say 2, add it to 2, and we will get 4. Okay, so simple equation here of adding. The next one we have is something called an AND block. This takes 2 on and off inputs and outputs 1 on off. This will only output if both of the inputs are true. For example, if we only have A, it will not output anything. If we only have B, it won't output anything. As soon as we have both of those true, it will then only send a true or an on signal out of it. The next thing we have is something called a blinker. The blinker will go and take an on-off signal and will then go and send it out, but it will go and turn it on and turn it off, turn it on, turn it off in a blinking fashion. You can actually click on the blinker and change the settings for this. So I've gone and set it to 0.5 seconds on and 0.5 seconds off. So we're going to turn it on. It goes and blinks on and off. Very good for creating sirens or any type of light system here in Stormworks. The next thing we have is something called a capacitor. Capacitor has 2 sliders, one for charge time and one for discharge time. So for example, I've gone and set this to 0.5 seconds to charge and 1 second to discharge, meaning that I have to give it at least a 0.5 on in order for it to get something, and then it will discharge that for at least 1 second. Once again, you can click on it, change it. I'm going to hold this down for 0.5 seconds. You'll now notice it outputed it for 1 second there. The next thing we have is something called a clamp. This allows you to go and set a range of a number. For example, I've gone and set this to 1 to 10. So if I was to give it a 5 number, it would output 5. However, if I gave this 55, it would only output 10 because that's the maximum number I told it can go out, because I clamped it between 1 and 10. The next thing we have is a constant number. Click on it, change the value, and it output that number. This is very good for maybe controlling pivots or any type of creation where you're doing some decoration. Very useful. You have a constant on signal. This will constantly always send an on signal out. Once again, very useful if you want all your lights to always be on, or you always want your engines to always be on, etc. That's very useful. The next thing we have is something called a counter. This will literally go and count all the way up to an unlimited number. Now, how fast it counts is what you can control using the input of the number. So for example, if I go and say count at every second, it will literally go and count 1 second at a time. Okay, as you can see here, going up and up and up and up. And it'll continue going unless you give it 0. Okay, so if you were to go and change that to 0, it stops counting. If you want it to count quicker, go and increase it. Now you can see how quickly it's counting. Okay, so you can change that to whatever you need it to. The next thing we have is something called a counter ping pong. Works exactly the same as before. The only difference is the maximum it can go is 1 and the minimum it can go is -1. And it ping pongs or jumps back and forth between 1 and -1 at the speed you choose. So if we were going to tell it to jump that speed at 0.01, you'll notice it goes up to 1, goes back down to -1, goes back to 1, and then goes back to -1. If you want to change the speed at how quickly it does that, once again, increase the speed, and you'll see how quickly now it's going back and forth. The next thing we have is something called a delay. This will take an on-off signal, wait for a certain period of time, I think it's a maximum 10 seconds, and then it will go out and send an on signal. So for example, I've set this to 1 second. So once I click this button, it's going to wait 1 second, then it's going to send it out. And there you go. I let go, and it's still holding it for a second, and then it's not sending it out anymore. So just a simple delay. The next thing we have is divide. So first off, a divide block, you can take any number and divide it by another number. So for example, we wanted to divide 10 by 2. Okay, it's dividing it, and it's giving us 5. However, it also goes and outputs an error. So for example, if I was to try and divide 0 by 0, it would give us nothing, and it would give us an error message here. Okay, so that is quite useful. You don't have to use the out for the error, but it's up to you. Along with that, we have a function. Function blocks, both of these here, which we'll talk about in a few seconds, are very, very useful components. This can take one number, then do something to it, and output a new number. So for example, I've got this function block to go and times it by 2. So whatever number I give it, 5, it's going to go and times it by 2. You can do anything. So you could do this for your speed. For example, you want to take meters per second and calculate it to knots, etc. You can use that. Maybe you want to take altitude, which is in meters, you want to convert it to feet. You can do that too. Very useful. Along with that, we then have a function 3 inputs. This allows you to take 3 numbers and then send out one number. So for example, instead of using that clamp there, I could actually use this function block and say take one number and clamp it between A and B, and then output a number. At the moment, I've got it to add all 3 of these together. So for example, 2 plus 5 plus 3 should give us 10. And there you go. It's all working in that nice little function block. The next thing we have is something called greater than. This will output an on signal if one number is greater than another number. So for example, if 5 is greater than 2, it outputs an on signal. If 5 is greater than 10, which it's not, it will not output a on signal. The next thing we have is something called a JK flip-flop. This will always output an on signal, but it depends on which channel it outputs that on. At the moment, it's outputting it on the off. If we were to go and set it, it outputs it on the on. Okay, so it's got 2 different channels on here, both on-offs. And you can keep on setting it, it will stay to the left. If you reset it, it stays to the right. The next thing we have is something called a less than. Very similar to the greater than, the only difference is now it's measuring if number A is less than number B. Yes, it is. What happens if it's not? It doesn't output anything. Okay, so 2 number inputs, 1 logical, on/off out. The next thing is we have a memory register. Memory register is something to go and store a number. So for example, let's say 125. We can tell it to set that number. It now outputs 125, and we can change that number to anything we want it to. And it will still output 125 because that's what we set it to remember. You can of course go and clear that number, and it goes back down to 0. You can reset it again, and it goes to whatever number you have, for example, my keypad. Okay, so you have options there. Just remember that when you are doing this, that you can clear it and you can set it as many times as you want to. Okay, so, and you can also click on this and you can change it to what you want it to reset to. The next component we have is something called a modular. A modular will go and take 2 numbers and divide them by each other. Okay, so for example, we'll take A and divide it by B, and then it will give you the remainder out into a number. Okay, once again, up to you if you want to use this one. The next one we have is something called multiply. This one you can go and take, let's say, 5 multiplied by 2, and you will get 10 as your number output. Okay, once again, you could do the same thing using a function block, but you can also have used the multiply block in game. Along with that is we have a not block. This will go and take a logical on/off, and it will give you the opposite of what you want. So for example, this is not on, but the light is on. If I turn this button on, the light is not on. So it gives you the opposite. Okay, not. The next one we have is a numerical inverter. Numerical inverter will take any number you want and invert it. So for example, if we were to give this 5, it would give us -5. If we were to give this -5, it would give us 5. Okay, so we'll always give you the opposite in the value. The next component we have is something called a numerical junction. What this does is it takes one number input and then either sends it out on A or sends it out on B, depending on what you have for the switch. Okay, so for example, if we were to give it 5, it would currently send it out on the off channel. If we turned it on, it would send it out on the on channel, and it switches them back and forth. A very good use case for this is maybe if you wanted to try and in your plane, you wanted your A and D to control, let's say, your roll, but when you click a button, you wanted your A and D to control, let's say, your tail at the end, your rudder that you have at the back of your plane. You could simply switch this and say, okay, well now we want our A and D to go to the back, or unturn it off, and now it's going to go and control the roll. Okay, so this is very useful to use a junction. The next thing we have is something called the Numerical Switch Box. This is very similar to the before, however, it takes 2 number inputs and then will only send out one of them depending if the system is on and off. So for example, we can give it an on value of 5, an off value of 2. Currently this is off, which means it's outputting 2. If we turn it on, it outputs 5, okay, because that's the number we gave it as the on. Once again, very common to use that and see that. The next component we have is an OR block. An OR block will take 2 on and offs and output 1 on and off. Doesn't matter which one of these are on, it will always output something. For example, if I turn this one on, it goes on. If I can turn the other one on, it goes on. If I turn both of them on, they're on. Okay, so it always sends something through if any of those inputs are positive. The next thing we have is something called a PID controller, or a PID controller. Now, these are usually quite complicated to use. I've got a very simple example just here in front of me. I've got a simple little pivot, and the pivot can tell me what angle it's facing. So at the moment it's facing angle 0. A PID controller is an easy way to go and read a variable and tell it to go to a set point. So for example, this is at 0. I want it to be at 0.3. So I'm going to go and tell it, I want you to be at 0.3. It's now going to see what the difference is between those two, and it's going to go and tell it to go to 0.3. And once it gets to 0.3, it's going to stop. Okay. We can of course go and hover over it by pressing page up, and you can see the current rotation, 2.999999, etc. So now if we wanted to come back to 0, we can simply go back to the set point, put this on 0, and you'll notice it's now going and turning until it reads that it gets back to 0. Okay, so PID is a very strong component logic block that you can use. As I said, it takes a little bit of tweaking to get it to work, but once you get the hang of them, they are very useful here in game. Along with that, we have something called a push to toggle. If you push a button, it toggles something on, and it will stay on until you push it again. Okay, so this is very useful. Now we do have toggle buttons in game plus push buttons, but there are some use cases where you might want to push something and leave it on always, and then push it again and then turn it off. The next thing is we have something called an SL latch, very similar to a JK flip-flop. However, this one you can actually go and set, and then you can reset it. So for example, I want to say turn on. It will now go and send a constant on signal there. Okay, I just pushed it. It's going and sending a constant on signal, and then I can reset it again. Then it's not sending anything out. Set it again, send something out, and so on. So these are very useful once again. The next thing we have is something called subtract. It takes one number and subtracts it by another number. It gives you an output. Okay, very simple, just equation there. The next thing we have is something called a threshold gate. This is another very common thing to use here in game. Threshold gate will take a number input, let's say 100, okay? And it will then go and read that to see if it is within a certain range. If it is within that range, it will go and turn the light on. At the moment, I've clicked on this and set it to 5 to 10. So if I give it 100, it doesn't output anything. But let's say I give it 7 or 6, it goes and outputs an on value. As soon as I bring that back out of the threshold, it doesn't output anything anymore. It's very useful. Trig. You can click on this, change whatever you want, cost, tan, sin, etc. Input a number, and then it will go and do the equation and give you the balance out. Okay. Along with that, we also have an UpDown Counter. UpDown Counter is once again very useful here in game. You can click on it, change what the max and the minimum is, okay, and you can also go and change the sensitivity. You'll notice it's currently at 0, and I can use the on-offs or the ups and downs to increase that. There we go, increasing it, decrease it please, and now it's bringing it down. It's kind of like using a seat, but instead you've got buttons that can go and do up and down or forwards and backwards. And going on to the last one, which is the XOR, okay, or XOR, depending on how you want to pronounce this. Now this will go and output a value as long as the other one isn't on. If both of them are on, it will not send anything out. If both of them are off, it will not send anything out. It's only allowed to have one of them on to actually send something through. Okay, once again, quite useful. So, ladies and gentlemen, that is all of the logic components here in game that you can find in your inventory. We will be doing a follow-up video to this where I'll be going into the microcontroller editor or the microprocessor editor, and I'll show you how to build one of those and go through all the different components inside there. Hopefully this video has been somewhat entertaining and informative as always. If it has, don't forget that like button and maybe hit that subscribe button if you want to follow any of my future content. So until the next one, we will see you then.